Now let's learn how to construct a table representation for a functions. Now this example in this video here is unlike the other example in the other video because the table on the other video must be given, because the problem was on the other video the function does not have a known rule. We do not know the function's rule in the other video clip. In this video, as an example, I do know the functions. So the function value here, the functions here has a rule about 5x minus 4, for example. So here's the rule for the functions. And once again, let me verbalize it out. The function's name is lowercase f. It takes the inputs. It takes x as the inputs argument, meaning for any x inputs, for any value of x, the function is going to multiply that value of x by 5 and subtract 4 from it. And so now, constructing the table representation for this function. And by the way, alternatively, you can write this function notation here as y equals 5x minus 4. You can just simply replace that function symbol with a y. And so now, here, this is what I mean by, in this case here, in this example, we do know the function's rule, because the rule here is that whatever the value for the input, you're going to multiply that value by 5 and subtract 4 from it. And so now constructing the table this time can be done. We can actually do this table. So construct a table similar to what we had on the other video lesson. One column is all the x that we can choose. The other column here is going to be the evaluated function's value at different x values. And so now I'm going to create a few rows here. So on the x side right here, you can choose any x value for yourself independently. So I choose -2, I choose -1, and I choose an input x to be equal to 0. I choose 1 and I choose 2. And so now if x equals -2, then on the function side, this is what's going to happen. The rule here is that when you have a value, when you know a value for the x input argument, you're going to multiply the value of x by 5 and you subtract 4 from it. That's the rule for the function in this case. And so all that here would equals to, now -2 times 5 is -10 minus 4, so it's minus 14 right here. So that's how you're filling in your other column, the right hand side column. And now similarly, when x equals -1, this is a different value for the input. You're going to multiply that input by 5 and subtract 4 from it, and this time it gives you -9. Okay, and then similarly, when x has value 0, when x takes value 0, you're going to go 0 times 5 minus 4, and your answer is -4. So -4 is what you fill in on this side of your column. And then when x equals 1, when x takes value 1, you go 5 times 1 minus 4, and that would equals to +1. And this is where you're filling it in, that +1. And when x takes value equals 2, when x equals 2, you're going to multiply that input 2 by 5 and subtract 4 from it. And here you have 6. And that's your answer, at 6. Now, the question here is that, do we stop our table here? What about, can you or can I choose x equals -3? And the answer this time is sure, why not? Because we do know the rule for the function. I do know the rule for the function. So no, any value you can take for x, any value you can try for x, and you can always rely on the rule to get an output value. And so here, and by the way, you can call the side once again, it's the input, and here's the corresponding output. So now, once again, before I stop my table right there, but now I can keep adding more values into the x. So here I have -3 times 5 and minus 4, and that's going to give me -19. So -19. And can you extend further? How about you putting a +3? Yes, we can. So here I have 3 times 5, which is a 15, minus 4, that gives me 11. And so when you actually know the function's rule, the rule for the function, this table here can be built infinitely long by just keep extending further and further down and choosing more different x values here. And so that's how you can construct a table representation for a function with a known rule. Now, after you construct the table, and here we come back to those similar questions as we had in the other video lessons, can we evaluate or can we find f of minus 2? Okay, and so f of minus 2 means this time the minus 2 inside parentheses here is telling me that my x input variable equals 2. My x input value equals 2. So that means there are two ways you can do. Either you can directly plug this in, minus 2 times 5, because you know the rule for the function. You can just do that and evaluate. But that can be long. So now we already had that laid down on the table, didn't we? So similar to what we've done earlier. On the table, on the x side, here's negative 2. And so we already calculated the value corresponding to that. So now my answer is here, f of minus 2 equals negative 14. You can just simply look it up on the table and find the value quickly instead of really going through and do the math again. So similarly, if you want to find f of, how about positive 1? F of 1. So once again, skip for yourself all that math because the table has it all there. So 1 right here on the chart equals 1. So corresponding to 1. So that's your answer. So there are similarities with the table we had in the other videos, and there are differences. And so I can also create from the table that we constructed. We can also have the questions such as find x such as or satisfying f taking x value. Find the value of x so that the function f of x equals 6. Okay, so now here once again you can just simply rely on the table. Right here on the table, where do I see 6? 6 is right here on the f of x side. So the corresponding value would be for x would be 2. So now my answer here, x equals 2, and that's my answer. The only thing now is that similar questions, part C, we want to find the value for x. We want to find what value of x satisfying f of x what equals to, how about 16 here? Okay, so 16, this time, once again, we're looking on the right hand side column, and I cannot see 16 anywhere. And so, does that mean I cannot know the answer? I cannot find the answer? Not quite. In this case, we know that f of x always equals to, on the left hand side, f of x equals 5x minus 4. That's the rule for f of x, or that's the whole quantity equals to f of x. And we want the entire quantity to be equal to 16. That's our desired value for f of x. So f of x equals to 16, and at the same time, according to the rule, we know f of x equals to 5 times x minus 4. And so now, right here, I produce for myself an equation, and here I need to solve for x. I need to find the x value that makes the two sides equal to each other. So solving that, I'm just simply adding 4 to both sides, and that gives me 5x equals 20, and dividing both sides by 5, and that gives me x equals 4. And so correspondingly, what I can see here, aside from the table, away from the table, I can still find a value for x this time, knowing the value for the function by simply solving for x. So I set the function rule, I set the function equals to that value, and start solving for x, and here I end up with my x value here. And now once you found that x value, you can also go back and put it on the table. X equals 4, that would give 16 for the function's value. Okay, so that's the idea of how you can construct a table representation for a functions with known rule.